Today, we stand at the threshold of a golden age in space exploration. The ability of humans to return to the moon is one of the most noteworthy missions. Renowned for its pioneering missions in this endeavor is NASA's Space Launch System, or SLS. To be honest, it's quite difficult to put into words what one feels about this rocket. It's a massive and complex machine that represents a significant technological achievement for NASA. However, it cannot be denied that it comes with a colossal cost, continuous delays, and a sense of obsolescence that seems to mark an end rather than a beginning. This is perhaps the final gasp of NASA's Apollo era, which has hindered the space agency for 6 decades. NASA has finally acknowledged what everyone already knows. SLS is unaffordable and no longer capable of surpassing Elon Musk's SpaceX. Stay tuned as we dive into this and more in today's episode of Alpha Tech. To continue operating the Artemis mission, NASA is planning to spend billions of dollars on the upcoming SLS rocket to the moon. However, according to a report by the Government Accountability Office published on Thursday, at current costs, the SLS rocket's key for the Artemis moon missions is unacceptable. Senior agency officials have told us that at current cost levels, the SLS program is unsustainable and exceeds what NASA officials believe will be available for its Artemis missions. It's a problem that NASA officials say they're working to better control, but the GAO says the agency still hasn't implemented its past recommendations, including plans to measure production costs to monitor affordability for their most powerful rockets. The SLS, the world's most powerful rocket, will allow NASA to return astronauts to the moon. In November last year, NASA successfully demonstrated SLS Block 1 during its Artemis 1 flight test. It can be understood that Artemis 1 has generated a lot of excitement within the space community. However, the question that arises is whether this project should continue, even after it successfully achieved a portion of its landing mission. While Artemis 1 was ultimately a successful launch, the SLS program has faced a variety of challenges which led to significant cost growth and years of delays to that launch, according to the report. Indeed, the annual cost of maintaining SLS is more than $4 billion. For a comparison of cost possibilities when transporting payloads, the Block 1 SLS can lift 95,000 kilograms to low Earth orbit, while the future Block 2 is planned to lift 130,000 kilograms into the same orbit. Comparable figures for the Delta IV Heavy and Falcon Heavy are just under 26,000 kilos and over 63,000 kilograms, respectively. Falcon Heavy costs well under $200 million a launch, a price that includes amortized costs of development and infrastructure. While the exact figure cannot effectively be calculated, the likely cost per kilogram of payload delivered to orbit by SLS is literally astronomical compared to what's available on the commercial market. Recently, NASA requested $11.2 billion in the fiscal year 2024 President budget's request to fund the program through fiscal year 2028. According to the report, that's on top of the $11.8 billion spent in 2011 developing the initial SLS. With such a substantial amount of funding involved, we might indeed want them to halt the SLS project. Many argue that the SLS program's goals aren't inherently aligned with space exploration, lunar landings, heavy lift capabilities, or other aspects of space travel. Instead, SLS seems to function as a mechanism primarily focused on channeling significant funding into various congressional districts. The program appears designed to incentivize delays and cost overruns. Completing it could mean the financial inflow comes to a halt. If NASA is serious about the program's stated objectives, it should pivot away from the SLS dead end and find ways to invest more deeply in the Starship program. To be candid, the moon program that NASA has entrusted to SpaceX appears to be superior to SLS, and it holds even more promise than any other program. With every launch, NASA has to spend over $1 billion to send just one SLS up, and everything, bar the Orion capsule, is turned into $1 billion scrap. This was state-of-the-art in the 60s, and this is still all NASA's aiming for. The Starship, on the other hand, does this neat little trick that SpaceX has been perfecting for years now. It returns to Earth and lands in one piece, both the Super Heavy booster and the Starship upper stage. The booster that launched the Crew Starship can also be the same booster that launches the Starship tanker, repeatedly if necessary. Nothing gets thrown away, everything gets returned for refueling and reflight. The expense equation now suddenly makes a giant backflip, as instead of building $1 billion rocket each time you want to send up a 40-ton payload to cislunar space, You now only have to worry about fuel and ground support expenses for your launch. The estimated cost for each Starship launch is around $2 million a launch, which includes somewhere between 750 to 900 grand for fuel and the rest for ground support, and 2,000 times less than the launch price of SLS. There are heaps of other reasons why the Starship totally makes the SLS obsolete, ranging from the fact that Starship uses revolutionary new engines that have never been flown by anyone else before, while the SLS is a holdover from the space shuttle. NASA has 16 leftover shuttle main engines and 14-foot-long cones that were cluttered in arrays on the bottom end of the shuttle orbiters. Those will be repurposed to power SLS. However, it's evident that not only is this technology outdated, but it also comes at a higher cost due to the refurbishment required for reuse. Besides, the SLS is a triumph of traditional, no-risk-taken conservative thinking that's delivered something that's based on 1980s technology and performs no better than a 1960s Saturn V. The Starship is a new take on rocketry that's physics-driven with a job to do, with no input from vote-seeking senators, a luxury that only a private company can afford so long as it's funded by a driven billionaire. This is one of the reasons why SpaceX has consistently been ahead of NASA since the early days of the company. A statistic from 2022 reveals that in space missions, NASA has witnessed an average cost overrun of over 90%, while SpaceX has incurred only a modest 1.1% cost overrun on average. SpaceX projects tend to take around 4 years on average, whereas NASA's typically take about 7. Interestingly, both NASA and SpaceX tend to promise faster delivery than what actually happens. SpaceX accomplishes in 4 years what they initially claimed would take 3, while NASA takes 6 or 7 for tests initially projected to take just 4 years. It's clear that Starship remains at the forefront, holding the promise of showcasing awe-inspiring achievements as its orbital missions approach. However, it's still too early for NASA to completely abandon the SLS, as they're persisting with this costly machine. Therefore, they must ensure full compliance that the requirements for disclosing expenditures associated with the SLS is mandated by government officials. In a report in April, the GAO found that to make human spaceflight programs more affordable, NASA needed to provide more information about long-term program costs and take actions to reduce those costs. But NASA's not pursued this course of action. Instead, they've informed the report's authors that they intend to monitor production costs and affordability of the SLS program via the 5-year production and operations cost estimate. Furthermore, according to the report, these tools are deemed inadequate for establishing a reliable cost baseline for the SLS rocket program. This deficiency raises concerns about the ability of taxpayers to accurately track costs and performance within NASA and among its contractors over time. Additionally, the report points out that NASA has not consistently updated its 5-year production cost estimates for the rocket. Another issue with NASA's cost estimates is their apparent failure to account for delays in the Artemis missions. For instance, it's highly likely that Artemis 2 mission, involving a crewed flight around the moon, won't launch before 2025. Intriguingly, the report mentions that some of NASA officials asserted that these mission delays would not impact the cost estimates of the SLS program, a claim that appears highly improbable. As per the report, some NASA officials told us that changes to the Artemis mission dates should not affect the SLS program's cost estimate, while others acknowledged that the program's cost estimate would be expected to rise to accommodate the delay in the Artemis 4 mission, which shifted from 2026 to 28. Faced with GAO's skepticism, NASA officials have also developed plans to address cost reduction for the SLS program over time. However, these plans remain speculative, with no specific public action taken by NASA at this stage. SLS is unaffordable. NASA recently admitted this. Since its build, the SLS has not only experienced soaring costs beyond control, but also significant delays. This has led to criticism of NASA, the leading aerospace agency in the United States, for their management of the cost and financial issues they've become stuck with. But in contrast to NASA, SpaceX has dealt with cost issues exceptionally well with its powerful rocket. Following the initial Starship explosion, concerns arose that SpaceX might be facing financial challenges. However, this isn't a big deal for SpaceX because, in fact, the company hasn't been significantly affected by losses. Even still, they actually turned a profit in early 2023. So with such a big banknote, how's SpaceX handling this cost that's embarrassing NASA? The Starship project is currently SpaceX's biggest investment. Although Starship holds the potential to be a reliable spacecraft in the future, the process of developing a Starship is by no means cheap. First, the employment of thousands of skilled professionals, from engineers to technicians with specialized expertise, plays a significant role in the mounting expenses. Furthermore, building, testing, and perfecting prototypes require a considerable investment in both time and resources. Frequent trials and experimentation are necessary to ensure the reliability and safety of Starship, all of which come with a hefty price tag. The materials used in constructing Starship also contribute to the overall cost. The spacecraft's colossal size and advanced technology necessitate the use of cutting-edge, high-quality materials. Additionally, infrastructure projects related to Starship development, particularly the construction of the massive Starbase launch facility in Texas, also incur significant expenses. Fortunately for SpaceX, they've managed to generate enough revenue to offset this. Despite these formidable financial challenges, Elon's transparency regarding the cost of Starship is quite noteworthy. Musk has pointed out that the company's planning to spend approximately $2 billion this year alone on Starship, and made it clear that they don't expect to need any outside funding to support these costs. This brings to mind the significantly more costly NASA moon rocket, the SLS. To be straight, the annual budget for the SLS development has been double that of SpaceX, yet it still falls short, as NASA is requesting another $11.2 billion in the fiscal year 2024 budget, in addition to the $11.8 billion spent on initial development. High costs are often associated with quality and timelines, but the SLS rocket still struggles to meet these expectations even with the government funding. Back to SpaceX. Following back-to-back annual losses, SpaceX has reportedly turned a profit during the first quarter of the year, despite an increase in costs as the company continues to spend on its Starship rocket. According to rare financial documents related to SpaceX, the company achieved its first profitable quarter in Q1 with a profit of $55 million on total revenue of $1.5 billion in 2023. This raises the question of how SpaceX managed its finances while awaiting the launch of Starship and still turned a profit. The year before, SpaceX reported an increase in its expenses from $3.3 billion in 2021 to $5.2 billion in 2022. The company's revenues, however, doubled to $4.6 billion, which reduced SpaceX's annual losses to $559 million in 2022, down from $968 million in 2021, according to the financial documents. The documents also revealed that in 21 and 22, the company spent a total of $5.4 billion on purchases of property and equipment, as well as research and development, a portion of which went towards the development of Starship, although the documents don't specify exactly how much. In general, while SpaceX may not have been profitable, its revenue has continued to increase year by year, aligning with the growth of its overall launch operations. SpaceX's financial sustenance hinges on a diverse array of funding sources. One pivotal source is the capital injection from investors, which has played a crucial role in keeping the company privately owned. This funding helps SpaceX maintain its ambitious pursuit in the ever-competitive space industry. Notably, the company's been successful in attracting substantial investments, reflecting a high confidence level in its mission and capabilities. Another significant source of revenue comes from the highly successful Falcon rocket missions. SpaceX's Falcon rockets have become workhorses in the space launch industry, consistently delivering payloads into orbit. SpaceX's Falcon 9 performed a record-breaking 60 launches last year. The workhorse rocket is in even higher demand this year, as other launch vehicles, such as ULA's Vulcan Centaur, failed to make their debut. SpaceX has also raised the price for trips to orbit on board the Falcon 9 by about 8% this year, with a launch now costing $67 million. The revenue generated from these missions has bolstered the company's financial standing, allowing it to continue pushing the boundaries of space exploration. One of the most promising financial prospects for SpaceX is related to the launch of Starlink satellites. SpaceX is launching 21 or 22 of its mini Starlink V2 satellites per Falcon 9 launch. There are approximately 37,000 more satellites planned to be launched before the constellation is completed. The original plan was never to rely solely on the Falcon 9 for the launches. The Falcon 9 was seen as a suitable starting point to kickstart the project until Starship was ready. With its significantly larger size and lower cost, Starship's expected to carry hundreds of Starlink satellites in a single launch. This is expected to significantly increase the speed at which the Starlink constellation is deployed and the quality of the service it provides. Euroconsult, a leading global strategy consulting and market intelligence firm specializing in the space sector, estimates that up to 40% of SpaceX's revenue, approximately $3.2 billion, could come from Starlink's broadband connectivity services. Starlink's already available in nearly 60 countries and key maritime areas worldwide. Looking into the numbers in more detail, it's projected that about 75% of Starlink's expected 2023 revenue will come from a combination of service subscriptions across residential and mobile segments, with the remaining 25% driven by hardware sales associated with subscriber additions. Starlink's user base is expected to double from an estimated 1.1 million in January 23 to approximately 2.2 million by the end of the year. This growth is attributed to aggressive hardware price reductions, new distribution channels, increased capacity supply, and expansion into more countries. To further enhance revenue for Starlink, Falcon 9 alone's not enough. SpaceX will also require the immense capability of Starship to launch larger Starlink satellites. Hundreds of thousands of people have already made deposits for Starlink service, but they're waiting for the launch of larger satellites that only Starship can carry to ensure that there's enough capacity to serve them. What Elon Musk was saying last year is that we can't run a profitable Starlink business unless we really upsize our satellites, our power, and our capability, and Starship is the key to getting it. Starship made its first test flight in April, about a year after Musk expected it to occur, which wasn't an obvious setback for the engineering program, despite its fiery ending. This aligns with SpaceX's core development strategy, as they consistently build and test hardware in the real world. While this approach has led to some significant failures, according to their engineers, it accelerates progress towards achieving a fully operational vehicle. In fact, building a new rocket, particularly one as complex and powerful as Starship, is never a linear process, and delays can be more costly to a company with a large workforce like SpaceX. Musk compared the Starship program to Soviet efforts to build the N-1 moon rocket in the 60s, a massive vehicle intended to compete with the U.S. Saturn V. The new vehicle was ultimately canceled after 4 failed launch attempts. Hence, the significance of a successful Starship launch into orbit can't be overstated. It would mark a major turning point for Starship. It won't be long until the next Starship launch attempt. While awaiting the FAA's final response, SpaceX has already completed most of the 57 out of 63 action items that the FAA required. Everything's poised, ready, with changes, upgrades, and improvements to the rocket and ground infrastructure system fully tested. The ambitious timeline for this launch could be as soon as this September. NASA's previously acknowledged that SLS is unaffordable. A few days ago, due to skyrocketing costs that have exceeded initial estimates by more than $5 billion. It seems like NASA's SLS has never created peace of mind for the American people. On the contrary, SpaceX and Elon do this more firmly and reliably. Things seem to be getting worse for NASA, as they just announced nearly 40 problems they're having with the SLS rocket. This sounds silly, but it's true. So, what exactly are those problems? Will NASA be able to solve them all? And how long is it going to take? By the way, how can SpaceX assist NASA? We had to wait a long time to see NASA's massive space launch system take off into the sky at Kennedy Space Center last November. Although the mission was successful, there may have been many technical issues with the moon rocket, as revealed in a response to a recent Freedom of Information Act request on September 14th. The report outlines a total of 37 abnormalities across various systems, including errors from Exploration Ground Systems, Flight Operation Directorate, Orion spacecraft, SLS rocket, and debris. To be honest, the rocket system's made up of thousands of components, so 37 abnormalities are likely only the major and more serious issues that occurred during the rocket's mission. First of all, Orion's been assessed to perform quite well on the Artemis 1 mission, impressing NASA with its energy production capacity. However, other systems, such as some circuit breakers, have posed problems as the spacecraft moved around the moon and returned. Some of the issues with Orion are related to valves, sensors, and pressure regulators. Another area of concern was the Orion spacecraft's heat shield. The team found that the heat shield had worn in a different way than models had predicted. The heat shield's ablative, meaning it's designed and expected to erode somewhat during re-entry into the atmosphere. Part of that heating to 5,000 degrees Fahrenheit that you'd encounter on a re-entry is that you're going to see a charring kind of material, Howard Hu, the manager of Orion program, explained. Kind of what you do when you barbecue. However, what was seen on the Orion's heat shield was that some small pieces were coming off, rather than a general ablation. The team's now looking through sensor data and using visual inspection to understand this issue further. He emphasized that the degradation of the heat shield was within acceptable limits. We had a significant amount of margin left over, he said. This margin is designed to allow for variations in the atmospheric environment that the spacecraft will pass through, while still keeping the crew inside safe from the heat. Secondly, the SLS rocket launch tower has stirred quite a bit of controversy following the Artemis 1 mission, as many media outlets reported the extent of damage to the launch platform. After the flight, NASA engineers and technicians had to climb hundreds of steps up the tower to assess the damage and make repairs following an elevator malfunction caused by the launch. During the launch of Artemis 1, some damage to this structure was caused by the tremendous 3,000 degree Fahrenheit heat from the SLS's boosters. The pressure from firing the engines blew the doors off 2 of the elevators within the mobile launcher. There are a few things that did receive more damage than expected, including some of the pneumatic lines. After launch, the pad lost gaseous nitrogen supply, which delayed the flow of the water that would have rinsed off some of the old solid rocket booster residue early. Because of that, some of the pneumatic lines got corroded. There was additional damage to the blast plates around the flame hole, which were damaged by heat. Moving on to the rocket, the star of the show, NASA reported 7 anomalies. These included loss of communications with a sensor system that reports propellant temperatures, unexpected debris on a plug that prevents containments from entering an engine's combustion chamber from under the rocket, and vibrations throughout the rocket in several components, such as those between the tanks and the flight termination system that's responsible for destroying it in flight if the vehicle threatens life or safety on Earth. Does this mean a bucket of water has been poured on Artemis's next mission? Indeed, there are numerous issues plaguing NASA's moon rocket system, and they've only recently made a clear announcement about it. When the rocket launches, it's only performing an unmanned mission. So the question arises, when the next SLS mission includes a crew, does it have the capability to ensure their safety? This is perhaps a challenging question to answer, as we still have no info on the repairs and fixes for the tech issues with both the SLS rocket and the Orion spacecraft. Many believe that these technical issues aren't necessarily a reflection of NASA's engineers' competence, but rather a result of the outdated technology of the SLS rocket, which harks all the way back to the 70s. Much of SLS is a holdover from the space shuttle. NASA had 16 leftover shuttle main engines and 14-foot-long cones that were clustered in arrays on the bottom end of the shuttle orbiters. Those will be repurposed to power SLS. But while the shuttle orbiter engines and external tanks were designed to be reusable, SLS and its engines were not. The first Artemis flight used old shuttle engines. The next planned launches will use others. On the other hand, not only does it operate with an old program, but the moon rocket also has the problem of sky-high costs. The financial constraint is also one of the reasons behind the delays and might indirectly contribute to the technical issues of the SLS, as they wait for funding solutions for the high expenses. NASA argues that it's using the most tested rocket engines in history, and that recycling them for the moon saves money. But not that much money, it turns out. In early 2022, NASA's Inspector General told Congress that the first 3 flights of the SLS would be $4.1 billion apiece, a level he called unsustainable. NASA and Boeing later said that the price tag would be lower, and outside analysts have said each launch would cost between $876 million and $2 billion, depending on how you break down overhead costs. They've designed a rocket that is basically unsustainable because it's a complete throwaway. The only bit that comes back is Orion, says Clive Neal, a lunar geologist at Notre Dame and an outspoken critic of NASA's moon plans. I get incredibly frustrated. Furthermore, an independent report by NASA's Inspector General in May 2023 also cautioned NASA about excessive spending on the RS-25 main engines and solid rocket boosters. If those costs aren't kept in check, it could pose a threat to the plans for returning to the moon. The report found that efforts to refurbish RS-25 engines, manufacture new ones, and produce solid rocket boosters for the initial Artemis missions have resulted in about $6 billion in cost increases and more than 6 years in schedule delays compared to NASA's original projections. There are other headache-inducing issues raised in the report. For example, the current cost to produce a new RS-25 main engine, which will be used for Artemis 5 missions onwards, is approximately $100 million. NASA and Aerojet are attempting to save 30% of the cost by the end of the decade, reducing it to about $70.5 million. Compared to the private sector, even reducing the price of an RS-25 engine to $70.5 million is considered excessively high. Blue Origin manufactures engines with similar power and size, like the BE-4, priced at under $20 million. SpaceX is also working on pushing the cost of their powerful Raptor rocket engines even lower, potentially less than $1 million an engine. Based on all the new data in this report, the adjusted estimate for the total cost of a single launch of the SLS, including ground systems and the Orion spacecraft, is now $4.2 billion. In general, with its expensive cost and unproven technical reliability, SLS continues to raise doubts among many about its ability to fulfill its missions. However, a brighter spot in this story is the potential for reusable heavy-lift rockets like SpaceX's Starship, which is being built to include a configuration to carry astronauts across the moon. Lori Garver, a former NASA deputy admin, expressed surprise that NASA, under President Joe Biden, chose a version of Starship to transport Artemis astronauts to the lunar surface, stating, "It's an acknowledgement that Starship's going to work, and if Starship's going to work, then you don't need SLS and Orion." That's all for today's episode. We hope you enjoyed it and learned something new. Please let us know what you think in the comment section below. Your feedback's very important to us and helps us make better videos for you. Thanks so much for watching, and see you next time.